All right, so example number 5 is a little bit different than example number 4. And you're fixing to see why. Now I can combine these logarithms like we do with the first property, where with the plus sign you go ahead and multiply those inside pieces. So it's log base 4 of, full that out, it's x squared plus 2x minus 8 is equal to 2. However, I had a log on one side and the other a while ago, which is why I could drop the logarithms, because if you have log of something equals log of something, the only way those can be equal is if the somethings are the same. That's not the case here. If you have a logarithm on one side, not the other, you're going to have to remember the definitions, the basic definition of what a logarithm is from the last lesson. Something like if I gave you log base 2 of x equals 3, where we would take it and go to exponential form by taking the base to the power is equal to what was inside the logarithm to begin with. In other words, to get rid of a logarithm on one side, not the other, you're just going to rewrite it going base to a power, that'd be 4 squared, is equal to what was inside the logarithm. Now it's just regular quadratic again. 4 squared is 16. Need to get it equal to 0, so subtract the 16 from both sides. You get x squared plus 2x minus 24. Factor each piece, you get x plus 6 and x minus 4. So your possible answers are -6 and a positive 4. Don't forget to check your answers. If I plug in -6, that's -6 minus 2. That's a -8. Can't have that. But if you plug in 4 minus 2 is 2, 4 plus 4 is 8. Both those are positive, so that's good. All you're checking for is to make sure that it's not a negative or 0 inside the logarithm. So here's problem number 6. Very similar to that problem right there. You multiply those together. It's going to be log base 2 of, pull those out, it gives you x squared minus 9. Since you have a logarithm on one side but not the other, you're going to take base to the power, it's 2 to the 4th is equal to x squared minus 9. 2 to the 4th is 16, gives you x squared minus 9. You need to get it equal to 0, so it's x squared minus 25. Factor that, it's going to be x plus 5 and x minus 5. So your possible solutions are -5 and 5. But if you plug in -5, -5 minus 3 is -8. And if you plug in 5, 5 minus 3 works, 5 plus 3 works. So 5 is the only good answer. Don't just assume because the x turned out to be negative, it's bad. Sometimes the negative works and the positive doesn't. Sometimes they both work, sometimes neither works. You got to plug them in and see if it's a negative inside the logarithm.